33, we're given the function is given now by a set of ordered pairs. The last few problems that we've done, the function was given by symbolic expressions, but now we're just given the function in a different way, and we're asked to find f of 9. So we want to find, if we put in a 9, what do we get back out? Now, to read this, the inputs are the first elements, right? They come from the domain, the first elements. So the domain here is 7, 2, and 9. The range, second elements, 8, 9, negative 5. So if we put in a 9, now that comes from the set of first elements, right? The domain. So pick a domain number. We're going to pick 9. So look up here for a first element of 9. Here it is right here. So what does f do to a 9? It converts it to a negative 5. Right? So f of 9, put in a 9, you get out a negative 5. 35, the function is given, again, by a set of ordered pairs, and what we're going to try to find here is f of negative 6. So if we put in negative 6, what do we get back out? So you go up to the function, you look for the first elements, right, because those are the domains, the input elements. Well, there it is right there. What does f do to negative 6? It says take negative 6, convert it to a 1. So we're going to claim now that f of negative 6 is equal to 1. Number 37 is interesting. We're given the function in terms of a mapping diagram. We're going to map the elements from the domain here, right? The circle on the left is the domain, the one on the right is the range. So here's what we're told, that some function, we're going to name it f, converts a negative 8 into a 5, and we're going to call this rule f. It takes a 7, converts it to a negative 2, and it takes a 0 and keeps it as a 0. And what we want to do here is we want to find f of 0. Well, it's pretty easy to see up here, I think. It's kind of hard to miss. You put in a 0 from the domain, what does it do? Maps it right over here to a 0. So we're going to claim then that f of 0 is 0. You put in 0, process it, you get out a 0.